Good day. My store, Gryphons and More, is authorized to produce the Signet blaster by Acorn Armaments, and the designer of the blaster gets a portion of the proceeds of the sale of blasters. That's how that generally works. I have an order for one right now, and so I need to build it, but I figured I would do a video about it so that other people building one could know how to build one too, because I don't know if there's a public video about how to build this blaster. Now, one thing that I will say is I source my own hardware, and they did a version of the parts to work with out of Dart's hardware, so their hardware may differ slightly from mine. I don't think it's substantial. So this kind of assumes that you've printed all the parts and have cleaned them up, removing like little fragments of filament, and if you have any supports or brims on your parts, this kind of assumes you've already removed those. Something that might not be obvious is for the slide, Acorn designed this little kind of piece right here so that if you do a brim on the inside, it'll just loop here instead of, because you don't necessarily need brim on the outside. I find brim on the outside harder to remove than inside because I use one of these deburring things. So anyway, this little very thin piece of filament, you just want to remove that if that wasn't obvious. And then another piece where you want to do something like that is the, let's see, this is the top back of the blaster. I don't know the file name, but there's a little kind of a peg right here, and that's essentially a built-in support. You can just usually snap that right off. Now, one thing I will say is it's a very cool blaster. I don't know if Acorn's print tolerances differ slightly from mine, but I usually find that as modeled, the back of the slide kind of sticks a little bit when it's all the way closed. So I tend to sand or file out the inside back part where it's tightest of the top slide. I'm just going to use this broad file for it with the not very sharp side. Just kind of smooth that out a bit, widen it just ever so slightly. For this particular operation, your mileage may vary depending on your prints. For the main grip, I have already inserted the ball detents. So there are two ball detents here. Those serve as the mag retention tab or whatever. So generally you'll super glue those in or use some other kind of very strong glue, and you want to make sure that the balls on the springs can still be pressed in on both sides, or else your blaster won't be very happy. Now, I've already cut my barrel. I don't remember how long it is, but it's whatever. I want to say maybe it's 10 centimeters. I don't remember, but whatever the length is, that's your barrel. Now, personally, when I'm preparing a barrel, you want a chamfered edge for the place where the darts will be sliding in, and I use a bit like this to do that with my drill. I'm sure there are multiple methods to do that. I have already cut my plunger tube. I use aluminum plunger tube, and this is compatible with different types of plunger tube, but basically for the aluminum one, and I don't know if there's any plastic ones, but basically there is a printable drill guide. So you print this once, no matter how many you're assembling, and you drill a hole on either side of your plunger tube. That will come into play later. Now, there are a number of heat set inserts with this blaster. So I'm going to do those first. I usually use a soldering iron to insert the heat set inserts. I'm sure there are other ways to do it. I don't know what they are, so I'm using a soldering iron. And I don't know off the top of my head how many inserts are required. So I just get a bunch. So let's see, we'll start with the barrel. In this particular case, the buyer of the blaster requested a completely clear barrel. Usually I'd print it with at least some orange, if not entirely orange, but that's your call. So the barrel is going to take one heat set insert here on the bottom and one at the back here. Your, what would you call this, the pusher, I guess? If you're using the kind that uses hardware rather than the X-Shot donor blaster, that will take a heat set insert on both sides. The magwell will take a heat set insert on the top. I forget what this piece is called, but this is the, I guess, the catch. Basically, the catch will take a heat set insert right there at the bottom. Generally, if you build enough blasters, you'll kind of get a feel for which holes take a heat set insert just based on their size, but the hole in the middle of the catch block does not. The top cover thingy takes one heat set insert on the side where there's a wider hole. And last but definitely not least, the main grip takes a heat set insert, I guess 3 on each side. So here, 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 and then flip it over, and then the same holes. It might be possible that if you have long enough heat set inserts and long enough screws, maybe you could get just like 3 total. But I have 6 total on it. Okay, so I think that is all of the heat set inserts. Here are some pieces that need an O-ring. The pusher should have an O-ring over the kind of a lip on the back. The plunger head is going to take an O-ring, although I'm not going to put that one on quite yet because I haven't assembled it yet. And the pusher also needs an O-ring at the front, where it will interact with the blaster. Okay, I haven't built one of these in a while, so I might be doing things out of order a little bit. So hopefully I will edit them in the correct order. Okay, so let's assemble some of the basic parts. The catch is this, and has this pivot, and has a little pin. The generic hardware version, you print the pin, and my understanding is the out of darts version has a metal pin. It shouldn't really matter much. This is printed on the strong axis and is unlikely to break. All right, so for your spring that goes in the catch, I like to put this in first. And basically, if you look inside the catch in the back, there's a little circular depression. You want to fit your spring into there. It'll just kind of hang out loosely for now. Assembling the rest of it for now is a little bit tricky. So basically take your pivot, and I like to get a flathead screwdriver, and I kind of push the spring down into the catch and then slide the tab of the pivot over it. So it's going to be kind of like that. I don't know if you can really see. You want to be able to see straight through the small hole because that's where your pin goes. And I can see through it, and it should push it the rest into alignment, probably. The really important thing here is that when you push on the bottom of it with your finger, it needs to be able to return to its position by means of the spring, because that's how the catch operates. Essentially, once the blaster is built, when you push the trigger, you'll just be pushing on that little tab right there. Okay, so I went and got my main spring for the blaster. I personally use K31 with these, and I build them for approximately what I call HVZ spec. I get about like 90 maybe FPS out of this on 14.5 coils of K31. It's 14.5 coils because basically you get about something like 44 coils in a stick of K31 spring. And so it divides approximately evenly by 3. So you can get 3 Signet springs out of 1 stick of K31. So let's assemble the plunger head. The plunger head is the flat round part and this, I don't know, this part here. And the way this works is you insert, this will only go in, well, it'll go in one of 2 ways, but basically it doesn't matter if it's, there's no upside down to this. You put it in the way it fits. This should be a pretty snug fit. And then the intention here is that you use a piece of filament to help secure it. So ideally your filament will insert into here smoothly. Mine doesn't always, and I'll have to tinker with this a bit, which I'll probably do off camera. If yours lines up for a piece of filament being inserted with little trouble, congratulations. So once you have your filament in there, I like to leave it kind of a little bit of distance from the far side. Pull it, so basically pull it back a little bit, cut it as close as I can, and then basically push it the rest of the way in. And to be honest, you don't really have to worry about the very tightest fit on this. And the reason for that is that this will be enclosed by the plunger tube, so it won't really have anywhere to go. Just using the tip of a very small screwdriver to push it in. But the bottom line is the filament piece should not protrude from either side. Once that's there, you're going to put one of your O-rings on it. All in all, I probably covered this earlier, but editing is going to be weird. I think you have 3 O-rings total. You have 1 O-ring of the bigger ones on the plunger head, and then on the pusher you have 1 of the bigger O-rings on the back and 1 small O-ring at the front where it goes into the barrel. I'm also kind of winging this because, like I say, I haven't done it in a while. So what we're going to do is take your plunger head, your main spring, and your catch block. Push this in here until it catches. Make sure it catches. If it doesn't catch, you're going to have a bad time. Make sure it catches and releases. You do want to have the notch on the plunger head facing downwards so that it can interact with the catch properly. Okay, so we're taking our catch block and we're going to line it up at the back of the grip. And we're also going to take this top cover piece and put it in there. And we're going to take our trigger and get a spring. I apologize if this ends up being the worst assembly video ever. So for your other small spring, that is for the trigger, and we're going to kind of maneuver this trigger in here with the spring in there, something like this. Okay, this wasn't very elegant, but basically what you want is your trigger having a spring here, and then your catch block is here. And make sure that your trigger can move freely back and forth like that. It doesn't move much, just enough to actuate the pivot inside the catch block. And then we're going to take our cover thingy here. Nothing's really holding the trigger there right now except for my hand. Now personally, I end up using a combination of these this kind of recessed head screws and ones with the kind of button on them. There are particular parts where you want it to be kind of recessed, so you need this head type, but then there are other parts where using this kind will make your prints more likely to break. For this one here, since the cover piece is printed on the flat axis, you can safely use this sunken head kind. Okay, so I have a screw in there, and I'm going to take another screw and apply this top cover. Basically, there's only one heatset insert here, so your screw's kind of going through the heatset and then holding something on both sides. Okay, let us start to use some lube, okay? I usually just use Super Lube O-ring style silicone. I'm sure there are many different lubes that are applicable. So I'm going to put some on each of these O-rings and swish it around. But then I'm also going to put some in the plunger tube itself, because I have found that extra lube in the plunger tube is seldom a bad thing. Also, you may notice that the pusher has a little groove cut out. That is to prevent vacuum loading. As far as I know, it doesn't matter if that ends up on the top or bottom. So I'm going to take my mainspring and put it on here, and I'm actually going to prime the pusher and lock it in. Okay, so that clicked. Do not press the trigger or this will fire across the room, and that'd be bad. Take your plunger tube. I didn't lube it yet. I'm going to put a fair amount of lube on the inside. Insert that, and I'm going to kind of swish it around a little bit. Use some of that lube. Swish, swish. Okay. Now, I personally like to put in some temporary screws for now. And so that's just to I'm basically going to secure the pusher into the plunger tube, but I'm just going to do it very loosely for now. That's not tight at all. That's just so that those stay together. I'll be taking those out later when it is time to apply this slide. Technically, any time we could put on our grip covers. So this is one of those situations where I prefer to use the kind with the sunken head instead of the button head, because if there's a button head, then it will kind of jam into your hand, which I don't really want. If you're putting in your grip covers now, I think we want to leave the front hole unsecured for now, because the magwell slides over that, and then there's a screw that will go through all of that. So this is a good time to put in your barrel. The barrel is, at least by my prints and my barrels, the barrel is a very snug fit in here and may take some force to insert. The barrel, if it's cut properly, should be roughly flush with the front of the printed piece. And like I say, it's a very tight fit. There is still this heat set and screw on the bottom to secure the barrel, although to be honest, in my builds, they stay really solidly without really needing that much. Okay, so now we will secure our barrel to our magwell. That's going to be one of those recessed screws. Ideally, don't over tighten it, because this is on printed lines and you could split the print. It may be possible to use a button head here, but I don't think there's enough room to clear the mag. Just make it relatively tight. Fortunately, that joint is not really under much stress. All right, we're getting there. Now we're going to put the whole thing together-ish. This kind of wobbly part here is going to slide into the opening between the parts you just assembled. This can be an incredibly tight fit. Don't force it, or else you may break something. I've actually ended up taking this top piece off, and I'm going to file it down a little bit on the edges until it fits here. Which it does now, and I keep stabbing myself. Try not to stab yourself. So we're just going to put that back on like that. If everything is going correctly, the holes in the magwell should be able to overlap with the holes that we didn't put a screw in here in the grip. Okay, so this is going to take a few screws. It's going to take one on top and then one in each side. For these ones, I would recommend using button head because otherwise you could end up splitting your prints due to how they are printed, due to the axis on which they are printed. All right, what I like to do here is slide the plunger tube forward and look on the inside and make sure that the O-ring on the pusher is able to interact with the barrel. In this case it is. I don't know if I can really show that, but if you look inside, the O-ring is completely inside the barrel, which is what we want. And at this point, if you plug it with your finger, you can fire it and check your seal. It's an okay seal, but this isn't a really huge, powerful blaster either. From this point, we just have to add our slide. So the two screws that I had put in temporarily before are coming out to be replaced by actual screws. Just make sure that everything lines up. The hole here needs to line up with the hole on the plunger tube and the heat set insert that's in that pusher. This is another case where I like to use a button head screw because if you put it in here with the sunken kind, it's going to sink into your layer line and possibly split it. All right, so the blaster is assembled. Hopefully, if you follow it along, should prime. You want to hear that click when it goes back. Push it forward, and put some darts through it. This does have a skinny pusher, so you'll be able to add a dart to the barrel even if it's already primed like it is now. I'm going to grab some darts. You should also check that the ball detents work for inserting and removing the mag. I mean, I think that's kind of a given. You want to check that things work. Yep, feels pretty good. Close slide, fire dart. Success! Mag needs to come out. The mag is a pretty tight fit, but that is kind of the intention with the ball detents. So hopefully I've been able to edit this into a semblance of something good. This is our Signet assembly video. Well, that's about it. I hope you enjoyed this. If you liked it, give it one of these, and I'll see you next time.